Hi, good afternoon. My name is Jennifer Eckhoff. I'm a surgical resident at the University Hospital Cologne in Germany and just concluded my postdoctoral research fellowship at SAIL, following very big footsteps after Dan Hashimoto. And I not only have the difficult task of condensing a 3-year multi-institutional effort into 10 minutes, but also of not keeping you from the well-deserved coffee break. So the SAGES CVS Challenge, I want to start with highlighting the multiple organizers and the amazing team that is behind this multi-institutional effort from 7 different institutions, but most importantly, actually naming my colleague, Dr. Deepak Alapat from Ai2m, who's not here today, but who should take ownership of the data processing pipeline and now the evaluation pipeline of the CVS Challenge, ultimately. And then also various industrial sponsors behind the challenge that enabled us to conduct this work over the past 3 years. So what is a data challenge? Ultimately, it's a competition among computer scientists on a defined data set with a specified, predefined target task, most commonly classification. And most of us actually use classification in our everyday life, in our smartphones, such as this classification of my dog, not only into category, but also into breed. What many don't know is that this task was based on a data challenge, namely the ImageNet data challenge from 2006, which is by now expanded to 14 million images and over 20,000 classes. There are various other examples of data challenges, especially in medical imaging as well. So radiology, for example, pathology, but in recent years also surgical data challenges centered around endoscopic video data, targeting the detection and classification and tracking of instruments, organs, different operative phases, procedural phases, action triplets, and also pathology detection, so polyp detection, for example. Most of these data challenges are based on very confined data sets from single institutions, which range between 15 and 100 videos and offer up to 40 minutes of video data. So democratizing surgical safety, Filippo gave me a very big word here in my talk. Democratizing ultimately means increasing access to surgical safety. And in our context today, we talk about surgical safety through surgical data science. So how do we do that? First and foremost, by increasing access, democratizing access to data. And not only access to the data, but also reflection within the data. So our goal was to collect a global data set, which is quite an ambitious goal, as you can imagine, and then also reflecting multidisciplinary expertise in this data set to then offer it to computer scientists worldwide for the development of AI with a specific task in mind, namely surgical safety. We're concentrating on the critical view of safety as a well-defined clinical task with very evident clinical correlations of common bile duct injuries if the CVS is not achieved. And we're actually targeting the binary classification of the 3 CVS criteria, being achieved or not achieved. I want to go into the 4 main components of a data challenge as we address them in the SAGES CVS challenge: data, annotations, the target task, and the evaluation pipeline. We talked about data all day long and different considerations that flow into data set composition. That quantity of data ultimately increases accuracy of the resulting algorithms, but diversity of data is actually maybe even equally important as quantity because it allows for generalizability and downstream application of these algorithms in a clinical setting. And then also the distribution being close to the real-world distribution, in our case CVS achieved, not achieved, and reasonable and reflective of a diverse set of clinical scenarios. And as you can imagine, various legal and ethical regulations are in the way of composing such a data set. They are quite variable across the globe, and we aim to address these. How do we do that? First and foremost, video contribution to the data set was based on donation. It was based on a data donation agreement, and access to the data set is based on a very strict participation agreement in the CVS challenge, which prohibits commercial use of the data. Secondly, we helped, very hands-on work, we helped with local IRBs in the different countries that you're going to see reflected in the data set in a minute. And we answered the question of data ownership by having the entire project umbrellaed by a surgical society, namely the Society of American Gastrointestinal Surgeons in the US. We then partnered with Surgical Safe Technologies in order to build a platform that would allow us for unified, standardized, and scalable data collection, the SAGES Video Acquisition Portal, which allows users to drag and drop their videos. It concatenates the individual video segments and then removes the out-of-body images, the entire metadata, and then adds the video to a data lake. In addition to the video, data donors were able to provide additional metadata at the discretion of their individual situation, so based on their individual institutional review boards and what was allowed within their framework. Additionally, besides the automatic processing and de-identification of these videos, we also manually looked at every single one of these videos to filter out de-identification issues that might have happened, for example, hospital stamps on it, date and time on it, but also filter out clinical factors that we, for this first edition of the challenge, wanted to exclude, and technical factors. Ultimately, we resulted with a data set of 1,000 videos from 67 surgeons, 23 countries, and 57 institutions. Most importantly, 30% middle to low income countries are reflected here. We have a vast amount of different resolutions and formats reflected in this data set, but also metadata with respect to which device was used, was the procedure laparoscopic, robotic, was IOC or ICG used as additional confirmation of correct identification of the anatomy. And then ultimately, and I'm going to, in the interest of time, skip this a little bit, we had the entire data set annotated by 3 different annotators, all of which were clinicians, with respect to the critical view of safety in the 90 seconds prior to the first surgical clip being applied, because we determined this to be the decisive moment where the surgeons make the executive decision of having correctly identified the anatomy or not. We trained annotators in a proficiency-based progression manner before they were let loose towards the data set, and they ultimately annotated in the entire 1,000 videos 3 times. We had 117 annotators that we trained, and only 19 active annotators remain, so quite a dropout rate, as you can imagine. And shout out to those 19 who are eager to actually keep going. Downstream tasks, CVS classification, I named this at the beginning, but besides CVS classification, we also want to quantify the uncertainty that underlies the inherent uncertainty when clinically classifying the CVS in terms of achieved or not achieved in the operating room, so the models should be able to reflect that as well. And lastly, robustness and stability across the distributions, the different demographics and clinical and technical factors that I mentioned previously. Ultimately, I'll leave the evaluation hanging for a little bit, a secret for another 2 weeks, because we have a challenge day on the 10th of October at MICA, and that would also definitely exceed the allocated time today. But please feel free to check out the website and also Grand Challenge website if you want to learn more about the metrics that we are applying, the challenge rules that are applying. What's the impact of all of this? How are we actually democratizing surgical safety? So first of all, I think it's one of the first efforts that actually brings together different disciplines in a multi-year project and a very concise data set that results from this. But in the background also surgeons and clinical trainees that impact this data set downstream. Now the only thing that's missing is essentially patients. How do we translate this back? With being the first data challenge run by a surgical society, we hope for many more iterations based on this data set and ultimately addressing the computational question of how to translate this into the operating room. We're addressing a clinically meaningful goal, meaning lab choles being performed all across the world with a diverse data set, an interdisciplinary approach, and hopefully, as I mentioned, a scalable framework that we will be using for future iterations of the challenge. And I'm very excited to continue conversations around this project. As 10% of the audience roundabout are probably from the organizing committee of the CVS Challenge, I don't think that will be a problem at all. Thank you very much.